All right, hi. This is a tutorial on the Google CoLab Painting with StyleGAN. This is the title with an emoji of paint. It says, hello, welcome to Painting with StyleGAN notebook. This notebook is intended to do two things. It's intended to help explore StyleGAN's latent space using variational autoencoders as a sort of filter to look at that space. And then on top of that, it's also a notebook to produce animations of interpolating through StyleGAN's latent space using the VAE filter, or as I call it, a palette, as a way to more graphically interface with that complicated space. Basically, what that means is we're taking 512 dimensions of the StyleGAN's latent space, which is too many dimensions to really explore visually. And we're going to use what's known as a variational autoencoder to take those 512 dimensions and reduce them down to two. And with two dimensions, what we can do is we can then plot it, and then you'll be able to see what images will be produced near each other, so that you'll be able to explore the vast array of your StyleGAN latent space, but doing it in a two-dimensional way. I hope that makes sense. So you'll see as we go along. So yeah, basically the first thing you're going to want to do is connect to a runtime. And after that, check what kind of, run it. I swear it's fine. So yeah, basically we have a P100. Good. You should be able to do this on a T4 too. But P100 is what I have been using. The next thing you're going to want to do is choose what StyleGAN and Tensor package versions you're using. So far I only have StyleGAN 3 with PyTorch and StyleGAN 2 with TensorFlow. So hopefully one of these things can get you what you need. Okay, so I'm going to do StyleGAN 3 with PyTorch. We're just going to do a generic example. So these are just things to download certain packages to make sure that the versions are all correct. It's going to do some GitHub downloading. Yay. Okay, happened. Now we're going to import all the stuff that we need. That's done. Okay, and so here's where you load your model. So you're going to want to use Drive, probably. If you trained your StyleGAN in the SG3 CoLab notebook, then you have your pickle in your Drive. And so what you're going to want to do is then put the location of that pickle in right here. I am just going to download one of the generic Met Faces pre-trained pickles from NVIDIA. But I am still going to use Drive, so I'm going to keep that checked, and we're going to do that. Okay, mounted, downloading. So this is going to download the pre-trained Met Faces pickle from NVIDIA's website. Sweet, that looks like that's done. Okay, cool. So now what we're going to do is we're going to build the VAE palette, which is what we're going to use to explore StyleGAN's latent space. So you probably don't have to do a whole bunch with this. We're going to build a train and test data set for our VAE. So basically we're going to sample from StyleGAN's W space a certain amount of times, and then that's the 512 dimensional data set that we're going to use to train our VAE. Setting the truncation PSI and truncation cutoff, those are optional here. You can just leave that if you don't know what those are. Basically, they help you kind of wrangle in some of the wilder things that StyleGAN can come up with. So you can experiment with that if you want, but I'm just going to leave it as is. And this is going to take a while. I am still here, I think. Okay, sweet. So now we have our train and test data for our VAE. So we are going to set up our VAE. So this is where you can put the name. This will affect save files, naming of save files. So if you have something specifically that you want to name it, you can name it here. NNVAE is a different version of a VAE that I've implemented, but only with TensorFlow. So you can only use it if TensorFlow is your tensor package of choice. Basically, what this does is instead of enforcing that the VAE latent space has a Z standard normal distribution of mean 0, standard deviation of 1. What this does instead is it looks for nearest neighbors to cluster together the latent space. You can get more natural sort of two-dimensional latent spaces using this. So it's just interesting. You can mess around with it if you want. So we're going to set that up. And then here's where we actually train everything. So mode, you can either train your palette or you will be able to save these in the future so you don't have to retrain them if you don't want to. And there is a bit of randomness with every training. So each palette that you train, even on the exact same data set, may get you different results, which is kind of cool. So you can train multiple of these if you'd like, or if you have ones that are already trained, you can load them instead. And if you choose load, then you would put the path here in order to load it. So yeah, we're going to be training. These are the hyperparameters for training the VAE. You shouldn't really have to adjust these at all if you want, but the two that you could mess around with, I guess, if you want, are the reconstruction weight, which is how well the VAE is doing at representing all the information that is present within the 2D latent space. And the KLD weight, it just ensures continuity within that latent space. So, yeah, they should add up to 1. So right now we're leaning more towards continuity and less towards reconstruction. So we want to make sure that our palette that we're looking at is continuous from one point to another. Whereas if we wanted to weight the reconstruction a little bit more, you might capture a little bit more information from that 512 dimensional space down to the 2 dimensions. So yeah, I'm just gonna hit train, and then this is gonna go for ever. So patience is an interesting thing you can mess with too. What that does is basically we're going to be training for a number of epochs, which is like going through the entire data set once. And so basically what this is looking for is at what point in time does the model stop learning? And you can see what we're expecting is the val loss. This is the validation set that we built. The loss should be decreasing each time. And if ever it doesn't decrease, then the patient's count is going to go up 1. So far we have 55.08, then it goes 55.06, 55.02. So everything's still going down. Training is going well. The minute that the validation loss does not go down, then we're going to get a tick on patient's count. And then the patients that we put up here equal to 15 means if that patient's count ever reaches 15, then we are going to stop training because the model's learned all it could. Oh, there you go. There, patients count 1 went from 54.72 to 54.73, and then it went back down to 54.71. So that patient's count reset, and you can just wait for this to be done. Still wasting so much fucking. Oh my god, is it gonna happen? No! You're just gonna let me down again. I'm not gonna get my hopes up. There's no way you reach 13. No chance. No way you. Oh my gosh. You can't tempt me like this. Don't. No. Ah, there we go. Okay. So we finally reached the patience the patience count we were looking for. So the model has stopped training, which is great. This means that our palette is ready to be explored. So let me skip this inject image really quick. What we can do with this is alter the palette in some sort of way. But let me show you the palette first. So I would, this optional one, inject image, I would skip it for now. If you hit it for some reason, the inject image option is unchecked anyway, so it shouldn't do anything. But yeah, let's go down to display palette. So what this is going to do when I hit play is this is going to graph the two-dimensional space that we trained, which is the representation of the StyleGAN latent space. You have 3 different parameters here that I'll explain as the image comes up. And these are going to help you explore what's possible in your space. So hold on one second. Okay, here we go. So this is what we have right here. This is basically showing you that there are different points in this two-dimensional space that represent different images that can be generated from StyleGAN. So up here at the space of -2 on the x-axis and 2 on the y-axis, you would get, if you plug that into the VAE and generate the corresponding latent space in StyleGAN, you would generate this dude's face, and so on and so forth. All of these different points represent a point in the StyleGAN latent space that represents an image. So yeah, what you can see is like this is a really interesting sort of array of different faces that somehow are near each other in the StyleGAN latent space. But you can see they're not very varied, right? They are all kind of like old white looking people. So my theory on that is that I think what the VAE is picking up on is the most likely sort of meta attributes of the entire StyleGAN latent space, aka what the training data most consisted of, and it chooses to pick up on that because it can't pick up on every single bit of information in the StyleGAN 512 dimensional space and only represent that in 2 dimensions. It's just too much information to compress down into 2 dimensions. So it's cutting corners at some places to kind of represent what are the most likely examples. But yeah, I mean, it's really interesting. There's obviously a transition from like male over in this direction to female over here. There's different pockets. So I'd be curious to see, because you can see our X and Y axes only go from -2, values of -2 to 2. If we zoomed out a little bit, maybe there's some stuff out here that's much different. So so that's what this parameter is all about. The dim parameter, you can really think about this as zoom. And this is going to be the number of steps out from 0 you want to go in each direction in your X and Y coordinates. So because it was 2, we went from -2 to 2. So if we wanted to go from -5 to 5 in both directions, we would just change this to a 5. So let me do that and just show you what that does. Takes a second. Okay, cool. So we backed out to 5, and yeah, we got a ton of different interesting looking faces, right? Like we didn't see this dude before. We didn't see this guy before. This woman looks different. So yeah, there's a lot more information out here. Now, a consequence of the VAE that you always want to keep in mind is that most of the variance of the data set that you're going to see happens in the center. That is a consequence of a variational autoencoder. It tries to represent this 2-dimensional space as a normal distribution. So most of the distribution is going to fall in the middle, and then as you go further and further out, it's less likely that you sample these things. So as you can see, the variance between this guy and this guy, in terms of difference in facial features and the meta attributes of the picture, aren't too different. Whereas obviously moving from this girl to this boy is very, very different. So as you zoom out, you're going to get examples that are much different, but then traveling in that space, you're not going to change as much over that space as you will once you're in the middle. So interesting, right? Like there seem to be a lot more interesting examples of faces. Now, what you might be interested in is, okay, well, there seems to be a huge difference between this picture and this picture. I wonder if there's stuff in between, right? So you could do one of two things here. You could either zoom in completely on this 0.566 to negative 0.566 range and take a look at what's going on in there. Or what you could do is stay this zoomed out and change the number of images that is on each axis. So you can think about this as granularity and steps, right? So instead of 10, if let's say I wanted to look at 15 images across and 15 images up and down, I would change it to that. And then we would hit play on that, and we'll see what that looks like. The final parameter here, display size, is really just about how big you want your overall picture to be. If you have a lot of pictures here, like num of 15, it may be kind of hard to see the faces. So you can go in here and hit large or extra large, and then you'll be more zoomed in on the actual photo itself, so you can kind of inspect it better. I keep it at medium because then I can see the entire space in a window. Once you go to large and extra large, you're kind of just like zoomed in on a spot and you have to scroll around to find it. So, yeah, because we have 15, this is going to take a second. Okay, but here you go. So now you can see we have a much more granular idea of what's going on here. So those images over here from negative 0.55 something, well, those don't even really exist anymore, but like that face basically was here, moving to the boy that was kind of like right here. Now you can see there's stuff in between. So you can get an idea of what's going on here. Now, one major limitation, right, is that, remember when we talked about at the beginning, this seems to just be a bunch of faces of just like old white people. And obviously the Met faces data set is a lot richer than everything that we're seeing here. So like I said, this is kind of a consequence of just the VAE in general. Once you compress all that information from 512 dimensions down to 2 dimensions, you can really only save so much information. So it's saving like what it views as the most important information, or the most common or likely representations in the data set. So here is where you can start to use the VAE as a more interesting sort of tool by injecting different images. So let me show you how that's going to work. We're going to go back down to 2 by 2, and we're going to display 10 images. And what we're going to do is we're going to go up here, we're going to click inject image. And this is going to pick a random image from the sampled StyleGAN latent space. And then the image weight is how far you want to shift your VAE in the direction of that image. So, I mean, if you go to 1, you're guaranteed to at least have that image represented, but then it kind of whitewashes everything into the same style as the image that you generated. So I like to stay around like 0.6, and it just kind of shifts it a little bit in that direction, but we can mess around with that. So I'm going to hit this. It's going to show me a picture of this woman right here. I'm like, well, she kind of looks like what we already have in our data set, so I'm going to regenerate. Okay, now that looks pretty different. Yeah, sure, let's try that. I'm very interested to see what's going to happen there. So we're going to inject this face into this entire palette, and it's going to color the rest of the faces to make it look a little bit more like this face. So let's try that. Oh, yeah. Okay, so now you can see all those faces that we had before. Do you remember most of the, like over here was men and over here was women? So that's still staying, but everything looks a little bit more in the style of this guy right here, which is super interesting. So now you've kind of like colored your palette in a way so that you can extract different animations that are a little bit more like what you injected up here. So let's do another one of these. I like to find like a black and white one because that shows it really well. That's an interesting one. Oh, that's interesting. That's kind of different. Here we go. So here's a black and white photo, right? Like we didn't have any black and white photos in our palette previously. So let us try to inject that and see what happens. Nice. Okay, so yeah, see, you can see it injected a little bit of black and white here. I guess if we wanted more black and white, we could up this image weight right here. Let's try that. We'll go to like 0.8, and then we're gonna have to find another black and white image. Oh, that's weird. Kind of. All right, I'll edit out all these problems. I just want a black and white image. Come on. Guess it would be interesting eventually to be able to just upload the image you want to inject rather than randomly scrolling through stuff. But it's part of the exploration. I think it's cool to kind of see what the StyleGAN can generate that you didn't capture in your VAE. Oh my gosh, come on. There we go. Here's black and white. Kind of weird looking. We might mess up our palette this way, but let's see. So we're going to inject this at 0.8. Let's go. Whoa. Yeah, so a lot more black and white. And you can see there's changes in terms of which direction the head is facing. But in terms of variation of gender, that's pretty much completely gone away because we injected this face that I think is probably probably in a very different location in the StyleGAN latent space than what we trained our VAE on. So it's capturing those meta differences in like facial angles, but it kind of got rid of all of the other information about like gender and things like that. Super interesting. All right, we're gonna go back for a final inject image on just something interesting. Yeah, let's do that. Oh, cool. Okay, yeah. So again, this got rid of gender, but gave us some really interesting stuff going on here. I'm gonna zoom out a little bit and see what we got in our space further out. See if we can make a good video out of this. It's a little too. Everything's a little too much the same. I guess there's slight differences in the angles of the face, but I really want something different. Okay, so what we're gonna do instead is we are gonna get rid of the inject image. So we're just gonna go back to the way things were before. Okay, great. So this is our palette the way that it was before. We're pretty happy with this. We like the exploration that we're getting. Like I said, if you wanted to train the VAE again, you will get a slightly different palette next time. That's just the nature of the VAE. There's randomness in how it initializes, so it's non-deterministic, the palette that you're going to get. So you could try training a bunch of different ones and see which ones you like. But let's say we're happy with this one for now. We're going to go down to save palette. That's checked, so it's going to save, and the name we're going to save it under is palette 1. So save, and then I'll show you where that's located. So for me, that's in my drive. It is going to go in a folder called AI, StyleGAN drawing, and then models, VAE palettes. So the one that we just did is this one right here, StyleGAN VAE palette 1. So StyleGAN VAE was the name of the VAE that we made, and then palette 1, this is palette 1. So if you went back up and you wanted to retrain another VAE and get a different palette, then you could save that palette too, and then you'll have them here, and then you can always load your palettes rather than train them all the way up here. So instead of train, you would pick load, and then you would put in the location here. So copy path, put the path in there, and then you'd be able to load this palette, and then you don't have to train again. So just to prove that it works, we can hit load on that, and oh look, it worked. Great. Okay, great. So now let's make an animation. So let's go back to inject image. We're going to try to find something that we think is interesting enough to inject into the palette and maybe get something cool. Oh my God, let's see what that does. Oh yeah, everything got super dark. Oh my God. Wow, I really like some of this stuff. We might have to make a visual out of this. This is gonna be our animation. I'm excited. Yeah, you can see we got some more facial hair going on. I really like the area up here. I'm gonna try to maybe make something up here. Cool. Yeah, this is great. This is what we're gonna use. Great. So now, once we have our palette that we want to work with to make our animation, with the injected color that allowed us to get to this interesting space over here, now we can come down here and we can actually draw on that palette to create the video. So what you can think about is like you're basically going to choose a starting point, and from that starting point you can draw to another area over here. So you can transform, maybe let's say this guy's face to this person's face, which is very, very different. I might be interested. I think what I'm going to try to do first is take something like this. Looks like a younger man version of this person. So I might draw from this person over to this person. So what you're going to have to do in order to do that is take note of the X and Y coordinates of your start and your end points. So so for this one, the start point over here is going to be 4. I'm looking at this guy right here, right? Or is it? No, it's this guy, yeah. 4 and 0.444 on the y-axis. So I'm going to come down here. We're going to go with our Paint with VAE palette section. There's going to be a start point X. And start point X we said was 4 right here. So we're going to type in 4. And then our start point Y was 0.444, if I remember correctly. Yeah, it was 0.444. Yep. And then our endpoint X and Y are going to be, I wanted this dude right here. This is going to be cool. Hopefully it looks like he's like growing up. That's kind of the idea here. 2.222 on the X-axis. I'm going to get rid of this. 2.222. And on the Y-axis, we have 3.111. Great. Okay, so we're going to be able to preview this before we actually create the animation. But before you preview it, you're going to have to type in a frames per second. And this is basically just the quality of the animation that you want to create. It doesn't really... it does affect how long it takes to generate, but most of these animations don't really take too long to generate. It should only be like 5 to 7 minutes or something like that. So I like to keep it up near 60 frames per second or 59.97. And then how long you want the animation to be itself. So how long is it going to take to get from that first point to that second point? 8 seconds I think is cool. So I'm going to leave that. What sort of path do you want to take? So this is interesting. There's a few different paths you can take. What we're going to do is we're going to do lines, so it's just straight from one face to the other. But other interesting ones are curves, so you could take like a curved path. You can't really design where you want the curve to go, but it will curve in some interesting way. So you can mess around with that and see what you get. And then probably the most interesting one, and I'll show you this after line, is circle, because what circle will do is it'll just draw a circle on the palette. So like starting somewhere and it'll draw a circle. So what that means is it'll go through the space and it'll end right back where it started. So you can get those really cool looping animations of going through the space, and then your end point is exactly where you started. So you can loop that over and over in like an endless loop. But let's start with line. Curve intensity will just change the curve for you. You can mess around with that. Flipping curve will change the curve for you. And then circle radius I'll show you that'll change how wide your circle is. But let's just start with the line. Okay, so just to show you what it's making, it's going to show you the start pick, which is indeed that's what we wanted to start with, right? It was this dude right here. Yep. So it's starting with this dude and it's ending with this dude, which is precisely what we wanted. Hopefully this looks like he grows up. And so then right here, what this is showing you is it's showing you the palette. And then it's showing you the path that you're taking on the palette. So it's saying, we're going from here to here. Is that what you want? And you can see, like, if you really wanted to get in the middle of here, you could probably subtract. So it's not 4 exactly. It's like 3.7 or something maybe. If you wanted to move this down, maybe you move down to like 2.9 or just 3 itself or something. This is fine for me. I like the start and the end points, so we're just going to watch it and see what happens. So we're happy with that, and we want to create our sketch. So now what we do to create our sketch is come down to Save Sketch, and you type in the sketch name that you want to save it as. So sketch 1 seems fine for me. Well, let's change it. Why not? We'll say growing up. We'll see if that... Okay. And so now it's generating this for you. So it's generating all the X points and Y points. You can see each one of these is a frame. So it's going to generate all these frames, and then it's going to take all those frames and generate it into a video for you. So we'll wait a few minutes, let this do its thing. And then when it's done, you will have a video you can look at. Okay, we're almost there. All right, so all of the frames are generated, and now it is saving the video to this location. So we can go check that out once it's done. And that took like 6 minutes to make. So yeah, about standard. If you increase the frames per second, it'll take longer. If you decrease the frames per second, it'll take shorter. If you increase the time, it will take longer, and decrease the time, it'll take shorter. So yeah, let's check out what we made. Okay, so my drive, AI, StyleGAN drawing, not models, sketches out. All right, here we go. This is the one. So let's download it. And let's take a look. Show in Finder. I'm gonna open with iTunes, maybe. I'm using QuickTime to do screen recording, so. Oh, sweet. Okay. Yeah, there we go. Oh, he's growing up now. Oh, what? What happened? That was looking cool. Maybe I can just watch it in Drive. Hold on. Okay, sketches out. Sorry, my internet is just trash. Growing up.move. Let's take a peek ski. Yeah, here we go. Okay, so it starts off slow, but then you can see, oh yeah. I mean, that's super cool. I really like that. So what I might do in this case is I'm like, okay, it didn't need all of that stuff at the beginning of the younger man. The part that I really liked is when it started shading like this. Yeah, this is the part where I really liked, where it kind of started making him older. And then you can see the shadows on his face kind of come in. I mean, this is just really cool. So what I would do in this case, maybe, I won't do it now, but you guys can, this is kind of like the fun of this, is you would go in and you kind of change the coordinates that you're looking at. And then get to a point where you like where, and I might extend the end too, because I think it ends a bit too abruptly. So you could maybe add on a little bit longer at the end. So yeah, let me show you kind of what I would like visually, what I think I would maybe do is I would go here, and you can see there's a lot more like older men kind of area over here. So probably what I would do is I would start a little bit higher up here. I might start at 1.33 rather than 0.444. Like there was just too much area here where it was a lot of youngness, and it didn't really transition super well. So I might change it to here to start at this one to cut off some of the younger area. And then I might extend it over to like here so it passes through this guy, but ends over here. So you get a little bit more time with the older face. And it would also, you could see, rotate the facial direction as well, which gets you really cool results. So yeah, I won't do that now, but just that's kind of how, you know, you can refine and keep messing with this stuff. What I do want to look at now is a circle. So yeah, let's see. Let's pick a cool area for circle, a different area. There seems to be really cool kind of changes in the direction of the faces kind of in this area. So I'm trying to think what might be cool here. That's kind of like, I like that there's an area here where this guy's facing to my right and then facing straight on and then facing to my left. And so I want to pass through this area because I think that's going to be super fun. So what I'm going to do, I think, is I'm going to draw a circle that basically just goes around this direction. And we'll see what we get. We might get some cool facial movements here. So the simplest way to do that is basically when you're making a circle, is you're going to want to pick your center of your circle. And so like you can see here, I have this like 3x3 square that I'm looking to create. So the center is this guy right here. So the center is going to be negative 1.33, negative 2.22. So start point, negative 1.333, and what do you say? Negative 2.222. Yeah. Negative 2.222. So for endpoints on circles, it's just ignored. So the start point X and start point Y are going to be your they're going to be the center of your circle. And then the other thing you need to worry about with circle is circle radius. So how big the circle is going to be. So if you look at here, what we want to get to is from negative 2.222 to negative 1.333. So that's a difference of roughly negative, is that, I don't want to do this math. Is it like 0.88 something? So negative 2.222, 2.222 minus negative 1.333. Yeah, there you go. 0.889. So that's what we're going to make our radius, and hopefully then this goes in this 3x3 circle. So 0.889. And again, you'll be able to preview this to make sure that you're getting what you want. So it's going to give you the start pick and the end pick. This is, oh, I was like, wait, that's not right. Yeah, sorry. I had to pick circle. There we go. Now it's starting and ending in the same place. That's what we hope. Okay, so this is actually a little bit like smaller of a circle than I wanted, so I might adjust the radius a little bit. We'll just go back to 1. And then I kind of want to move it over a little bit on the x-axis and increase a little bit on the y-axis. So we'll move this over to like maybe negative 1.111. And then the y-axis we want to move up. So yeah, negative 2, just negative 2 maybe. Let's see how that goes. Yeah, that's pretty much what I was looking for. So we're going to get that nice sort of head rotation here where it goes from facing kind of left to straight on to right, and then it's going to go around. So let's see what we're going to do. So this one, we're going to save this sketch as something else. We're going to save this sketch as rotating direction. Well, yeah, whatever. All right, now we just wait for this to to do its thing. Okay, sweet. So now we have our second sketch, the circle. So let's check this out. Again, I'm just going to look in Drive. Okay, rotating direction. Let's see if it'll play. I'm not sure if it's processed yet. Dang, come on. All right, we're going to try to open this in iTunes again. You know what I'll do is I'll probably just overlay here the raw video so you guys can see it, so it's not a screen record. But let's just check this out really quick. Oh yeah, interesting. We're definitely getting some of that rotation. Yeah, cool. So obviously not some of the collar stuff kind of bothered me, so I might go back. I might go back and change that up a little bit. I might even inject a different image up here rather than this dude, because you can see there's like quite a stark difference, like a sharp difference between his outline and the background, and I think there's some of that in that rotating video that I'm not super stoked on. So I might honestly just go in and inject a different image and then try to do a loop that way. But either way, that is how you would make a circular video and how you could iterate through it and come up with really cool animations using this VAE palette and different VAE palettes that you can create. So yeah, that is the end of the notebook. I hope that this has been useful. I hope that you guys have fun using this tool. I think it's super cool to be able to explore StyleGAN and see what it has to offer. I love making animations with StyleGAN. I hope more people start doing it. I also love diffusion methods as well, but there's something about the animation of StyleGAN that is just so pleasing, the morphing from one to another. And I hope that this is a tool that you can use to help you be more intentional in making those animations and have a little fun exploring. So thank you.